Hello guys, this is Code and Code and this is 19th lecture of this graph theory series part 1. In this lecture we are going to see how we will count connected components on given 2D grid. We have been following these lectures in which we are studying how DFS, BFS or die-cast algorithm can be applied on 2D grid. So this is one of those lectures. This is lecture 19, and if you want to get started with those lectures, just go and watch previous 2 or 3 lectures. So let's first define the connected component on 2D grid. So you see, here we are given 2D grid. Each element is filled either with 0 or with 1. So 0 are the cells on which we cannot step on. So these cells we cannot step on these cells, but we can step on these cells which are filled with 1. So a connected component, here we are considering the two cells are adjacent if they share a common edge. So you can move from this cell to this cell, but you can't move from this cell to this cell because these two cells do not share any common edge. Now these all 4 cells are forming a single connected component. In fact, let me show you by coloring. So these 4 cells are forming a single connected component. This is forming a different connected component because you see, from each cell colored in this brown color, I guess, from every single cell to every other single cell you can reach. So from here you can reach here by following this path. From here you can reach here, of course, by direct going from this cell to this cell, or from here you can reach here by taking this path. So the definition remains the same as there was in the time of where we were studying connected component on graph. So a connected component is a set of vertices where you can reach from for every single pair in the set there exists a path from one node to another. Similarly for this, for every single pair in a connected component, from one cell to another you can reach. So you can see you can reach from here to here. So all of these are part of a single connected component, but we can't say this for this because this is from this node or from this cell you cannot reach even this cell because there is no path. From here you can't go here, from here you can't go here, that is why you can't reach this cell. So these are forming single connected component, this is forming different, and so on. So in total there are 6 different connected components. So we'll see how we'll apply DFS and count the total number of connected components. This is very similar to what we did in graph algorithms where we applied DFS and counted connected component on a graph. So if we have to count connected component on a graph, what you will do, you'll simply initialize count to be 0, and from 1 to n for each node you will see whether that node is visited or not, and then you'll make a DFS call to that node and also increment the connected component count. Now whenever you make a DFS call to any node which is unvisited, if a node is unvisited, that means the whole connected component in which that node lies is unvisited. So what you do, you make a DFS call to that node, and what happens, all of the nodes which are reachable from that node, or basically the whole connected component, will get visited. And the whole when the whole connected component gets visited, that means all of the nodes in that connected component are getting visited and will be marked as true, right? That means next time when I will become either 3 or 5, visited of I will be true, and you won't make DFS call to those nodes. Basically, in a given connected component, when you make a DFS call to one node, all of those nodes in the same connected component gets traversed. So the whole connected component gets traversed. This DFS of I will be called only a single time for a single connected component. I have explained this in detail when we have studied how to count connected component in a given graph in previous lectures in the same series, so I'm not going into the details. So this is how you count connected component on a graph. Now the same goes for 2D grid. Now see, what happens is that how you count connected component in a graph is that for each single node you will see whether that is visited or not. If not, you make a DFS call to that node and also increment the count. The same would happen for this, for grid. Now, as explained in the lecture where I introduced DFS algorithms on DFS or other graph algorithms on 2D grid, I have explained explicitly that we consider cells same as we consider node in the given graph. So instead of running a loop for each node, of course we do not have nodes here, we will run a loop for every single cell. So we are running an n square loop for, in fact, n cross m loop, and see whether the I comma j cell is visited or not. If that is not visited, and of course it is equals to 1, because we cannot step on any node which is having value 0, so we cannot make a DFS call to node which is having value 0. So it is important to check whether the current cell is having value 1. If the current cell is having value 1 and also that cell is not visited, so we would make a DFS call to that node, that cell, as well as we will increment the connected component count. This is exactly similar what we did here, so nothing changed. So if I show you the code, this is valid as explained in the previous lecture. So this is valid function. I have only added this extra condition that if the next node on which you want to step is actually storing value 0 or 1. If it is storing value 0, then we will return false, because we cannot step on any cell which is having value 0. That is why this is the extra condition added. This is an extra line also added because we now need to store the whole array. So this is for input array, this is for visited, nothing changed here. This is from the previous lecture, everything here is from previous lecture, nothing changed. Now here we are reading n and m and also reading the input array. After that, as explained in the slides, this is what we are doing. We are running a loop and then checking for each cell whether it is visited or not, and also the value stored is 1 or not. If so, we are incrementing the connected component count, as well as we are making a DFS call to that cell. Finally, we are printing the connected component count. And if I show you, this is the input, this is the same input as this grid. So let's see how if you see here, we are having 1 2 3 4 5 6 different connected components. Let's see our program runs fine or not. 6 cross 6 and input array. So you see connected component count is 6. I'll be giving the link of this code into the description. So this is how you count connected component in 2D grid. So this was all for this lecture. If you have any doubt or query, of course you can ask in the article that I've created for this course on discuss.codechef.com. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.